So, this video is basically trying to get your thinking caps on and teaching you about a certain topic in physics which is fundamental to learn kinematics, and that is how to be an expert at, Newton's laws of motion, because these laws are basically what you need in life. These are your actions and why they actually work. This is actually from a long time ago, 16 to 1700s, and it's before modern physics and atoms. And basically, Sir Isaac Newton just inquired, like any other scientist, what motion was and how it worked, why forces are needed for motion, and are they needed for motion actually, and if people walk, are we actually using force, and is that why we have motion? Are we moving relative to the earth? Is motion actually relative? And to answer these things, we actually have to know what motion is and what its opposite is, which is, state of rest. This concludes to Newton's first law of motion, which actually states that every object will remain at the state of rest unless a force is acted upon it. Now let's break this down into rudimentary steps so that we can understand with an image, basically an image experiment, because it's pretty difficult. So we have a circular object. Now this object is in a surface with friction or without friction, let's say. And we apply a force, and that's the arrow right there. And this force can be like a hand or the wind. And gradually this circular object, will start moving on the surface. And if it has no friction, then it will move infinitely. But if it does have friction, it will stop, because friction acts as another force opposite to the initial force. Now, the second law of motion by Newton, which is this guy right here. This European man, like always, from the UK. He stated that acceleration is dependent on the net force acting upon an object and its mass. So this is just like the hardest law ever. Like, what does that even mean? What proves that? Do we have an equation for that? Like, what does mass have to do with anything? And acceleration? Like, what is acceleration anyways, Well, I'm going to tell you what you really need for this law, and that's F equals ma, which stands for net force, or force, equals mass times acceleration. Now, you should know this, but in other words, this actually means that if this force acting upon, the object, or the net force in specific to this law, increases, I'm showing you with this exponential graph right here, then A, or acceleration, will also increase, as you can see with the graph, that it's increasing. Now, we have Newton's third law, finally, which is actually my favorite, and I don't know if you can have favorite laws, but I do. This is the one. And my definition is that every force has its equal opposite force acted back upon it. So, yeah, it's not really complicated, but I probably made it seem complicated. But Lin-Manuel Miranda states that every action has its equal opposite reaction, in the Hamilton play. This means that forces occur in pairs, We have this man right here, he's not dancing, he's pushing, crying but pushing, and this other man is also pushing him. He's upside down, but it doesn't really matter, because this man is pushing and the other man is pushing, and it's at the same time. Don't worry that they're the same person, because just pretend they're twins. But they have the same force. They're pushing with the same force. And that's basically it. Newton wants you to know. But if you're still lost, I have like a little review for you. And yeah, so if you're still lost, because I'm not really probably the best teacher ever, you're gonna have to match the law with the correct definition here. I have this little game for you planned out. So we have Newton's first law, and then we have Newton's second law, obviously, and then what comes next? The Newton's third law. Great. Here are the definitions written really quickly, so you have to probably pause and check it out. Go back to the video to see, what the answers would be. But I'm going to tell you the answers anyways. Just please pause if, you're having trouble. And number 1 is third law, second is first law, and the third is the second law. Yep, these are the answers. If, you're still confused, just know that you have to practice this. There are example questions online, and there's many things that you can do, but you have to learn this basic topic in physics.